All right, who here has a Monzo card? All right, just half of you? Get on board, the other half. We're the most exciting thing, man. Okay, this is customer service, customer support augmentation. I'm going to be talking about this. And at Monzo, if you don't know us, we are trying to build the world's best bank. So one of the main things that I think sets us apart is our awesome customer service. And note that I say augmentation and not replacement because chatbots suck, right? So you ever go to a website and then a little box pops up, click here to chat with us. No, I don't want to chat with you, you know? That is just like Clippy, but like in website form. So that's not what we're trying to do here. Okay, customer support augmentation. We pride ourselves on having really good customer support. We have a whole Twitter page retweeting our praise for us. So if you want to check that out, this is one of the tweets I just found like 5 minutes ago. Very happy customer. But the thing is, customer support scales with number of users. So this is a chart. One line is number of active users, and the other line is new conversations that we get through intercom. So when one goes up, the other goes up as well. So the pressure, the problem for us is to how do we keep delivering that quality customer support? You know, how do we have every support come in and get a response in 10 minutes, no matter how large we grow? So there are two levers to this. One is to reduce the number of inbound questions, and the second one is to increase productivity of each individual agent. And in this presentation, we're going to talk about how we use machine learning to reach these two goals. Obviously, there are many ways to do it, but this deck will just focus on the machine learning part. And so reducing queries, we have natural language search in the app for help content. So if you have the app, feel free to play around with it. I have a quick video for you that shows how it works. All right, so you go to the search screen. If you search forget pin, keyword search, yep, it matches as a forgot pin right up there. But if you use a synonym, don't remember, the pin forgot comes up as well. And then if you search, what's you want? Grayed out. So when the price is grayed out, it's a pending transaction. The algorithm seems to pick this up, which is good. And also emojis. Japanese flag, I'm going abroad, perfect. And you go into the help. If it doesn't help you at all, you click the thumbs down button and it fills up the intercom chat section for you, and then you can just message us right away. So that's one way of reducing inbound queries. Hopefully we can help people find and the answer to the issue they're looking for before they even get to us. So next one. So to increase productivity, we suggest safe responses to a support agent. So this is a live screenshot of how it looks in the intercom app, which is the app we use to do customer support. A question comes in, the bot suggests safe responses down there. Don't mind the copying of the question. It's just so in the sidebar it still shows. We don't have to get into that. But it just shows the the safe responses in there. So we have a safe response called ATM US fees, ATM blog, why are you charging ATM fees? So these things save you a lot of typing. Although, if you message us, even if we do use a safe response, I want to stress that we always change it up and add a little bit of personality because, you know, we're not robots and we want you to have a good time. Yeah, try it. Well, okay, don't just try it on purpose, but if you need it, you'll see what I mean. There'll be emojis and GIFs all over the place. We have 800 of these safe responses, these little things at the bottom right here. We have 800 of these written and saved in intercom, and approximately 70 to 80% of queries we get can be answered with a safe response. So this is a really good way to increase productivity. A person can't remember all 800, right? So if you can help them pull out the correct safe responses when they need it, that's going to be a big win for us. So we achieve these two goals, the search model and the safe response model. It all comes from the same NLP model, just one single thing, which I think there's a lot of value to be derived if you use one single model for multiple purposes. The technical debt goes down. You maintain one thing instead of two things, and you know it's just me working on this really, so I can't really do more than one, you know. And I'm also not a very hard worker, so one is more than good enough. If it works. We formulate this an information retrieval problem. There's going to be some overlap with what you just presented earlier, but it's all cool. You know, deep learning is all the rage now. So that's what we're using as well. Who here is, by show of hands, who here considers themselves technical? I'm just gauging how I'm going to present this. Okay, and non-technical people? Okay, good. Half-half. Doesn't really help, but okay. Given an incoming question, find the most similar answer from an answer pool. So this works for both our intercom suggesting safe responses scenario and also the help search scenario, right? So we define most similar as a pairing question and answer that yields the highest cosine similarity. A cosine similarity is just a way of measuring the distance between two vectors, if you're not familiar. To find cosine similarity of text, we need to represent them as vectors. So I forgot my PIN, I can reset it for you. It needs to go through something we call an encoder, and it counts out as a sequence of numbers. Those are like different vectors. And ideally, you want those two vectors to be very close to each other. Word2vec, people familiar with this? Good, it's a way of representing words as vectors. So instead of like a word, you have a series of numbers, because apparently that's what computers are good at, just numbers, really. Word2vec works well on data. If you can see here, it's a bit small, but most similar word to the pound sign. The machine detects pounds, dollar sign, pound, quid, which is pretty impressive, you know? Even a foreign person wouldn't know what quid is in a pound, but the machine discovered that through conversation. So I like that a lot. This is a most similar word to 100. It's a number. It seems to detect that. London, you got Edinburgh, Manchester, Glasgow, Leeds, Belfast, you know, pretty good. This algorithm would win in a pub quiz. Now we go from word vectors to paragraph vectors. You can't just sum them up, because that doesn't work very well in experiments that we've conducted. So you have, I lost my PIN. You have 5 and an emoji. Emoji has a vector too, okay? So it's a real thing. I lost my PIN, sad face, 5 different vectors. How do we go from that to one single vector? We need an encoder. So this is the architecture that's currently being served like live right now after many trials and errors. This is the one we need. It's by Google. The paper is called Attention is All You Need, and the model architecture is called a transformer, which Google uses for their translation tasks. I don't know if they still use it. They probably have a better thing that they haven't published yet. Competitive secrets, right? But this is the paper we're using. Training the transformer. I'm going to go into some detail on how we train our model. Good, it's good on time. Before we were using a transformer, our models were written in Keras and Tensorflow. So data scientists in the room, you must be familiar with this. Keras is a deep learning package and TensorFlow. But for transformer, we migrated to Pytorch as of like 2 months ago. And we found it really good. The reason we migrated is because, well, I was curious about this new package. And people have been saying it's great. And it is. And I'm going to show you why. Before that, we have a sec-to-sec model architecture, which you covered earlier, so I'm not going to go into it. But we only take the encoder. So we have on the left is the encoder, on the right is a decoder. We only want the hidden representation of a sentence, right? So we are only taking the left part, which makes training twice as fast because you get rid of the whole thing. We have 400,000 parameters, which is pretty small. I'll come to the reason why in a second. 330,000 examples, approximately. We take like last year's worth of conversations and train on those. And then we train it for 300 epochs. That seems to work pretty well. Our data looks like this. Raw text data is HTML. And then we train with triplets. Here's how we train it, which is I think the most interesting part of this whole exercise. We feed in every single data example, we feed in as a triplet. So question, how do I change my PIN? And then we have A+, which is the correct answer. You can change your PIN at yada, yada, yada. And then A-, which is the wrong answer. You'll be pleased to know we don't charge you any fees from withdrawing from an ATM. So we feed these triplets in. We basically tell the machine to make the right answer closer to Q, make A+ closer to Q, and make A- further away from Q. And that's really the magic. We do it over and over again until it learns. And we use a ranking loss, hinge loss, objective function. An objective function is just a function you need to minimize when you train a model. So if the function is 0, great. But if it's not, you want to minimize it as small as possible. This is the function. This is the only equation in the deck, so don't worry. It's just basically M is a margin. You don't have to worry about that. Basically, if cosine distance of Q and the correct answer is large, the loss would be 0, and that's good. That's all you have to know about this. We train on Google. We use GCE, Google Cloud, the GPU through 2 or 3 days. That's why a small model really helps here. 2 or 3 days. In machine learning papers, it's It's funny how every time I read it, it's like, oh, we trained it on 32 GPU units for 4 months. Yeah, we can't do that at work. We will be fired. You know, imagine hiring someone and, oh, I'll have results for you in 6 months. Just hang on there, boss, you know. You can't do that. So 2 or 3 days is about right. So it's like fast enough to learn new things as as they come in. A few tricks we do. Every few epochs, we switch out the examples that doesn't benefit the algorithm at all. So like things that are too hard or too easy, that doesn't really help the machine algorithm learn. And we use the same weights for both questions and answer. The encoder has the same exact weights in them. And learning rate annealing, this is just a fancy way of saying if we just decrease the learning rate every few epochs, and we find it the simplest way, reduce when plateau, works better than fancy things like SGDR. SGDR is stochastic gradient descent with warm restarts. It's just a fancy way of switching a learning rate, which didn't really work, But you got to try, and I can tell for our case it doesn't work. Maybe it's different for you, so give it a shot. Serving the model, this is also a cool thing for me because prior to Monzo, I never had the chance to serve anything in production. So this is a lot of like heartbreak and sweat and tears, but we're there now, so it's all good. For customer support, this is the easy part. We just basically, because it's not consumer facing, we just run it on a compute instance. Every minute it just serves through an API, pushes it through intercom. So you get that speech bubble thing that you saw earlier. For the in-app help search, it's a bit more involved because we have a microservice architecture. So we serve the machine learning model behind a Flask API, and then Docker container on Kubernetes, which I think that this sentence alone can get me hired at any hip startup, you know what I mean? But I didn't really do much. Docker container, yeah, you make your own container. I know how to do one thing on Docker and like one thing on Kubernetes, that's it. I don't really know the details of it, but that's how we serve it. Also CPU only. When you're serving, you don't really need GPUs. That's what we find because you're only like working on inference and it's very little data that passes through it. So CPU is fine. In both cases, we're using Pytorch directly. And if you're into this research type stuff, you'll know a lot of people like export Pytorch to Cafe 2 through ONNX, the Open Neural Network Exchange system, to make it like run faster or something. But we found that for our volumes, just raw Pytorch in Python works pretty well. Because it's a microservice architecture, we can't just serve like a 4 GB memory file, it's called microservice for a reason, right? So when I'm making the Docker container, I artificially constrain myself to using only 1 CPU and 1.2 GB of RAM, and we need to make sure hopefully the model can run on it, and it does. Pytorch works really well. When I do a load test on it, 100 concurrent users, it can serve like 14.6 requests per second with no failures and a median response time of 50 milliseconds. So that's pretty cool. That's running on local host, so there's no like network latency and stuff. But that's a good start. And I think in comparison, we have 3 pods of these on Kubernetes. So it's like 3 replicas of this. I don't know much about Kubernetes, so don't ask me any questions about that. We have, in comparison, the same specs, 1 CPU and 1.2 GB of RAM, crashes a TensorFlow Flask app, and Keras, don't even ask, it's crazy. Keras is a wrapper around TensorFlow, so that performs even worse. So these specs, TensorFlow protobuf can't even run on. So PyTorch, pretty cool. We have some unit tests to check prediction qualities. So on the left here, you see all searches, common searches people do. So I want to make sure that we show them relevant results for common searches, and those are checks. So before we push any new model to production, needs to pass these checks. Otherwise, we don't push a new model. And then we also have a web UI to test it interactively. This one you can see HSBC. The model knows that it's a bank. And the results. Great. I always feel like there are 2 types of metrics that I think a data scientist we should be concerned about. There's the machine metric, and then there's a human metric. Right? So what do I mean by machine metric? It's like your test train and test accuracy, your top 3 accuracy, stuff that's really closely related to how you train your model. So if your model training gets better, these things will go up. And these are like, top 5 accuracy of our models over time. You can see it's always improving. So this is from like March till now. So yeah. It's like 87% top 5 accuracy right now, but that's a machine metric. So a human metric is a lot messier, So One of the examples I think of it when I say human metric is like our safe response usage. It does go up, but of course, it depends on a lot more things and how accurate your model is, right? It could be like he didn't see it, or the algorithm didn't like pick out the conversation fast enough. But overall, it goes up. And if your safe response usage went up, we can even use these as like to get insights from it. So we can see which safe response we use and how often. And then we like these things, because we're so high up, we have just fixed them in this latest version of our app. So the pin presend in our current account app that you guys will be upgrading to soon, we have fixed all these stuff. This black screen type stuff is fixed. Top up appearing as stripe, that's all fixed. So these things alone reduce our queries by 10%, and that's 800 a week. So that's a pretty good improvement for us. Adoption rate of safe responses is not as good as I like. It's like 2/3 of people. And this is what I mean by a human metric as well. How many people adopt it? You know, we had a Slack message just today, actually. Give me a thumbs up or thumbs down if you use, they call it Nigel Bot, which is, you know, the thing that I showed you earlier. So 2/3 of people use it for various reasons. It's basically right now, it's a hack through Intercom. We're going to build our own system and hopefully drive this percentage up. But the people who use it seem to like it. So that's good and protects my ego a little bit. We also use the safe response predictions as classification. So if we predict something like a pin request, that's an easy thing to solve. You know, oh, we can send you a pin, just confirm your date of birth, yada, yada, yada. So we'll be routed to this thing called the lightning queue, where it's a queue of more easier questions go to. In app, another human metric is they find relevant stuff maybe 2/3 of the time. And that's because sometimes we don't have a FAQ item for that. There's many things that are involved in this, but this thing, we are tracking this, and I think it should also get better over time because we're looking at what kinds of things people are searching. So Stripe appeared a lot in the past 2 weeks, and then as of today, we just deployed new help content in there that has a Stripe FAQ item in it. If you don't know, this Stripe is a payment processor, so there was a problem where when people topped up, instead of saying top up, it says Stripe, and people don't know what the hell Stripe is. Okay, great. I only have 2 minutes left. We have a dashboard to keep track of metrics. It's all good. Other learnings, don't train ranking problems as a classification problem. So with this stuff, don't label it as 1 and 0. Don't do that. A softmax seems to push things towards the edges, so it doesn't let you rank really well. That's something we found out. Before the transformer, we used a hierarchical attention network, which is also another pretty cool architecture, but our transformer does better. Keras is good, but not that great. Despite being dynamic, Pytorch performs better than Tensorflow in both training and serving, and the size of the binary is smaller, so the raw model file, 70 megs versus 110. And only scenario in which Tensorflow is faster is training on CPU. Pytorch sucks at CPUs for some reason, but who trains a model on a CPU anymore? You know, it's 2017. Just get a GPU, guys. Use the right level of abstraction. There's classification, ranking. We don't need text generation, so we don't go there. You pick the right level of abstraction for your text task. This one is a bit, I don't have time to go into this. Use Pytorch, it's great. This is a real code snippet. Sorry I'm like keep beating a dead horse here, but this is a real code snippet that we had in our repo. The code for loading the model. On the left, we have TensorFlow. This is how it looks. On the right, PyTorch. Yeah, you decide which one you want to use. Huh? All right, key takeaways. Build multi-purpose models to avoid technical debt, so you maintain one thing, and don't build models that depend on outputs of other models. That's just, you know, a disaster waiting to happen. So one model, just like Lord of the Rings, one model to rule them all, you know? Monitor your metrics and actual usage habits, the machine metrics and the human metrics. Use Pytorch. And that's my time. Thank you very much. Cool. Questions really quickly. Yes.
So I was wondering, before you had sufficient data to train these networks, what techniques were you using to do the same thing?
Before you had sufficient data. We always had sufficient data, so I never had to think of that. We used deep learning on as little as like, when I started training, we had like, what, 150,000 conversations. Deep learning still works fine. You know, you actually need a lot less data than people think they need usually for deep learning. It's a 10K, 50K, that's a good way to start. Yeah, yes?
How is the performance of your models really simple?
We did a benchmark of that for a tagging classification task, 30% better deep learning versus bag of words, naive Bayes type stuff. Yes.
You mentioned that your prediction model is based on the data you have, right?
Based on the what? Sorry?
The data you already have.
Yes.
You can use like Wikipedia to very well or something like that.
No, we did want to do that, but then word2vec works fine, and I would love to use, oh, sorry, finish?
Just following up the question.
Okay.
How your improvements, accuracy improves over time as you keep getting more data? Do you have like a metric to monitor?
Yes, we have, there's a slide earlier with the line chart. Oh, sorry guys, I put a lot of slides. I should be more, yeah, this is how it improves over time. But this is top 5 accuracy, so one of the machine metrics we track. As for, we could choose to use external data like glove and word2vec pre-trained vectors, but then you don't have the flexibility. Those vectors come in 300 dimensions or 1,000 dimensions. We only use 100, and you don't have the flexibility to do that. Yeah, that's what we did. We trained word2vec from scratch ourselves. And also, if you use like glove Wikipedia vectors, the word Monzo might not even appear. So I just don't want to worry about it. I just train it. I just do it ourselves. You know. Yes.
How do you handle it in different languages? Do you kind of Google Translate it all to English and work it out, or like localizations?
No, I'm just throw it in there. It seems some Spanish text works. So if you go to your help search right now and type something in Spanish, like a commonly used Spanish phrase, I tried it before and it seems to work. But it's 50-50 on that one, you know. So it's the same thing. Same thing like emojis. If it happens a lot, people use it a lot, the machine will detect what an emoji means. But it's the same thing for foreign stuff. We didn't do anything special with it. Yes.
When you say you tried topic models, do you mean you tried topic models where you like fed the latent factors into a logistic regression or something like that, or multinomial regression? Or
Topic models. I didn't say topic models. Did I say topic models? Am I getting a stroke or something? No.
What were the alternative models you said you tried that you said didn't work very well?
Oh, so we trained it for a classification task, and we tried a naive Bayes model. We also tried a logistic regression, basically everything in scikit-learn. You just threw everything in scikit-learn with the scikit-learn has a thing called a pipeline. You can just switch out the model and let it run by itself. So we threw everything at it and see what stuck, and then nothing did.
We're gonna have to.
Cool. Sorry, guys. Thank you very much.